Hello, my name is William Paavolainen and I'm here to provide you a presentation about reverse engineering. We'll be focusing on software reverse engineering and I'll try to make it as practical as possible. So, let's get started. First things first, the table of contents. As you can see above my head right there, we will be looking at importance and practical applications of reverse engineering as well as some C programming language. We are not going to go too deep on that one, but some basic stuff about C. Data types, functions, and loops, and an if-else statement as well. Then we have some assembly, mainly registers, flags, and some instructions as well, and we will talk about stack just a little bit. After that, we have disassembly tools, and at the end, I have demos. Although we will be looking at demos throughout the presentation and not at just the end. This will be mainly demo-focused presentation, but there are some theory that you just have to bear with me. So, importance and practical applications of reverse engineering. Why? Why would you learn reversing? Well, we have legacy systems. For example, many organizations in different industries rely on legacy systems, old software that may not have been properly documented. But by the power of reverse engineering, you can still figure out how it actually works. Then we have security analysis. We can use reverse engineering to identify vulnerabilities in software. For example, bug hunters do this all the time. And we can also do malware analysis with this. Then we have debugging, so we can analyze and fix bugs that are in closed source software, for example. Modding, we can customize and extend software functionality, so we can actually make the software do stuff that it wasn't originally capable of. We can extend different functionality to the software itself. Then we have career, of course. It can open up the job market for cybersecurity or digital forensics, malware analysis, even software development jobs for you. And last, but definitely not least, it's fun. This is, of course, a bit subjective, as it depends on who you ask, but many people that I know, at least who enjoy doing this, think of it as a game of sorts, like a puzzle game, where your problem-solving skills and critical thinking skills come to mind when you try to analyze these complex systems that others have wrote for you without source code. But yeah, let's dive into C programming language. We'll start from data types. We are just going to look through a few of these, not too many, starting with void. So void holds no value whatsoever. It's often used for specifying a type of function. For example, void type functions. Void functions also do not return value by themselves. Then we have int, which is just an integer. We have double, which is integer but with decimals. We also have float, which is double but with more decimals. Then we have char, which is a character. Really, honestly, it's just an integer as well. But we use those char data types to store characters. Then functions. You can make as many functions as you want. There's no, at least, practical limit to those. I think there might be some kind of theoretical limit, but it's not going to come to you. But most important function, perhaps main function. Every single C program has at least a main function. It works as an entry point for program execution. So when you run your program, if it's a C program that is, you're going to enter the program, you load the libraries it uses, and then you start running your code from the main function. And there you can see the int argc and char argv Those are argument count and argument value. When we use command line arguments, you are going to see something like on the screen right now. So int main, then argc, argv, so on and so forth. We're going to look at that a bit more closely at a later time. Next, we have printf, which prints formatted output to standard out, or wherever you choose to print it out. It's an integer type function as well. Lastly, we have string compare, strcmp, string compare. Also, once again, an integer type function. And the job of it is it compares two strings together and returns an integer. It returns 0 if those two strings you compare are equal. So if they are the same string, compares them, returns 0. If they are not the same, it returns something else. And that's the gist of it. Then we have loops. While loop, we have while, then some kind of condition, and then we do something. And while that condition is true, we cycle again and again and again until it's not true. So in this case, we have an example while integer I, which has some value, but while that integer is less than 10, we print hello. And the last part there, the I++, means that we add 1 to the value of I. So every cycle we do, we print hello and add 1 to the value of I. And at some point or another, the condition is no more true and we won't go through that cycle again. So we move on. Then we have for loop, which is kind of the same. We have initialization, then condition, and then increment. So for, then we have the integer I, which we initialize to 0. And while that integer I is less than 10, we print hello. And then at the end of the cycle, we simply increment the value of I. So we add 1 to it. Then this is not a loop, but a statement. These are if and else statements. So we have if, condition, do something. So if something is true, we do something, and if it's not, we just won't do that. So in this case, if our good old integer I equals 2, we print yes. Else, we print no. So if our integer I is, for example, 10, the program checks it. Does I equal 2? Nope, it doesn't. So it just goes to the else segment. And we will have an example of this as well. But that's the first part. Then to the demos. There we go. I have a Kali Linux virtual machine right here. And I have prepared some demos for you guys. See here. Let's check out the source code. A very simple one. So here we have our main function. Here's an if statement. Here's a for loop. Here's an else statement. Those are the basic blocks we have right here. So let's start from the main. It's an integer type function. So int main. Then we have argument count, argument value. And for the first if statement, if our argument count is greater than 1, we go to this for loop. If it's not greater than 1, we will print out too few arguments. Let's see if it works. So program 1, let's just press enter. We have too few arguments. We need 1 argument to it. Let's give it test. And now it works. Let's look back. So we hit on the first time we hit the else statement, and on the second time we hit the if statement. So this was true on the second time. We went to the for loop, which printed out argument C and our argument B. So our argument count and our argument value. Let's run it again. Let's give it test 1 and test 2. Press enter. And again, we get our argument counts and argument values. This specific program doesn't really do anything with the arguments that we give it, this test 1 and test 2. All it does, it prints them out. Here we can see something quote-unquote weird, perhaps, for some people. This is argument count 0, and our argument value is program 1. And this is true for every single C program that you actually run, in terminal at least, in Linux. So argument C0 will always equal argument value, the program name. Then argument count 1 will be our test 1 string right here. And when argc is 2, we get our test 2 value in here, just like we checked out here. If we check out the loop a bit closer, right here, we can see that our integer I is initialized as 0, while our integer I is less than the number of arguments we give it. We run these 2 lines, and after each cycle we increment the I with 1. So at some point our I integer will be equal or greater than the number of arguments we give it. And then we just won't do this anymore. And what does this mean? Well, printf, we will print formatted text. First we have argument count. This %d means digit, so we print this integer value there. \n means new line. And then we have argument value. This %s means string, and this will be our string. And the integer here, the value of the integer, will be replaced in here. At the end, we have return 0. We have an integer type main function, and integer type main functions return integer values. In this case, we return 0. That just means that we are now done with the function. So the function will end